Welcome everybody. If I haven't had a chance to meet you, introduce myself. My name is Jeff Parrish. No one calls me by that. My name is Jefe. I'm not the boss of anything, so I had to change my name to Jefe. I'm the Vice President for Conservation at WCN, and it is the greatest honor of my life to have been able to work with some of these amazing conservation heroes through WCN. It's not about WCN's logo, it is about theirs. It's about supporting these amazing entrepreneurial, independent conservationists who are fighting the good fight for our wildlife. And each of them works with an endangered species. And for those, I'm going to put on my PhD hat and let you know that endangered is not just a catch-all term. It actually means that these populations are there are specific criteria. They're really small. Their numbers are really small. They've been declining at really fast rates. And those things mean that these particular species are extremely vulnerable to what is the clear and present danger that our planet faces today, and that is climate change. So we have a lot of doom and gloom when we talk about climate change. Sometimes we have a few wins. This past week, can anyone tell me something that happened with respect to climate change? The Paris Treaty was ratified. That's fantastic, but our job's not done. We have so much more to do in terms of implementing that, mitigating the impacts of what will be a completely different and warmer world. And more importantly, when it comes to wildlife, adapting and ensuring that these species can survive in a warmer, more crowded world. We're going to talk about some of those direct impacts, but also some unexpected impacts, some impacts that we really didn't even foresee. We often think about, okay, the ice is melting, habitat's lost for polar bears, but that's not where it stops. There's a lot of things, these extra effects that are happening to these species, and we're going to hear about those from some species you might immediately think about when you think of climate change, like a polar bear, all the way down to the cutest little monkey on the planet. I told a few people last night, I get a beer every time I say the cutest little monkey on the planet from Rosamira, so I am easily bribed, but we'll hear about the cutest little monkey on the planet, but many other species that you might not have thought would ever be as impacted by climate change as a polar bear. So I would just want to pause and welcome our incredible panel of conservation heroes and ask each of them to introduce themselves, tell you where they are, where they're from, and a little bit about what they do, and then we're going to get on with the conversation.
I'm Steve Amstrup. I'm the chief scientist at Polar Bears International, a small nonprofit dedicated to saving polar bears from extinction by preserving their sea ice habitat. Prior to joining Polar Bears International, I led polar bear research in Alaska for the U.S. federal government for 30 years.
Good day, I'm Elena Bykova, I'm from Uzbekistan. Naturally, I'm a zoologist with 25 experience of working to studying and research mammal species, and 10 of which I spent for Saiga research. I'm working like executive secretary of Saiga Conservation Alliance. We are working on the ground for protection beautiful, unique creature, big-nosed Saiga antelope.
Good morning, everybody. My name is Pablo Borboroglu. I live in Argentina, in Patagonia, and I am the director of the Global Penguin Society. It is an international organization that protects the 18 species of penguins that exist in our planet, and 60% of them are threatened. Penguins live from Antarctica, close to the South Pole, up to the equator, and they face different threats depending where they live, and if they live in developing or in developed countries. So we work at different scales to protect the vast areas of the ocean that they use to feed and to migrate. And also we work at small scales to protect the place where they nest and they breed.
Hi everybody, I am Rosamira Guillen. I come from Colombia and I am the executive director of Proyecto Titi, a nonprofit organization that works in northern Colombia to protect the cutest little monkey on earth.
When she says it, I lose a beer. And
I take one back. And which is critically endangered, that is one step away from being extinct in the wild due to extensive deforestation of the tropical forest in northern Colombia and for its capture for the pet trade. And at Proyecto Titi, we work very hard to reduce those threats by creating more forest, protecting forest, and also doing field research permanently and working with the local communities to both educate the next generation of Colombians and also work with the community to provide alternative income to hunting animals or cutting trees.
So great to have all of you here. I'd love for us to start by actually just getting a quick overview so that everybody has the cliff notes around climate change, and no one's better to give us a little background than Steve.
So we're calling this a climate change panel, and there's a lot of discussion about, well, do we talk about global warming or do we talk about climate change? And the way I like to think of it is that climate change is the cast of symptoms that result from the human warming of the planet. By increasing atmospheric concentrations of greenhouse gases, we guarantee that the heat content of the globe can only increase. It's regulated by the laws of physics. So we know that we're on an upward climb as far as global temperatures. The repercussions for that include all of the things that we talk about climate change, like more frequent droughts, more frequent storm events and floods. Louisiana, for example, has had 2 1,000-year flood events in the last year. But I think that we probably don't want to bet that they're not going to have any more for the next 2,000 years. We're seeing an increasing frequency of those sorts of things, long predicted, and so it's all of those things that are wrapped up when we talk about climate change. Polar bears have become kind of the symbol of climate change, and the reason for that is that they depend for catching their food on the surface of the sea ice. And the sea ice can only melt as temperatures get warmer. My research showed that there's a linear relationship between sea ice extent and global mean temperature. So the most direct effect on polar bears is the loss of habitat that they need to catch their food, which means more periods of food deprivation.
So those are the direct effects on polar bears. We're going to talk a little later about some surprising and shocking indirect effects. But Elena, maybe tell us a little bit about the direct effects on Saiga.
Sure. Saiga inhabited in Eurasia. It's a central part of Eurasian continent that occupied most arid and semi-arid zone. It's not surprisingly why Saiga affected from climate change very strong, because especially these habitats affected from the side of climate warming, first of all, very strong. This is lead habitat degradation. This is lead habitat fragmentation and habitat loss. Saiga very strong depend on the grass, on its food, and of course it's very critical issue for Saiga have very high quality of grass. But under climate change effect, grass started to dry more fastly, and quality of grass decreased strong. In general, area of Saiga shifted from south to the north. That is very bad. We have very strong decreasing Saiga area as well. One more critical issue for the Saiga, especially during the breeding time, is watering place, a source of water that's completely important for the Saiga female during the birth season and during the season field melting. But again, under effect of the climate change, this watering place started to be dry very early spring, and breeding place shifting to the north as well. That means some countries completely lost breeded Saiga in their areas.
So serious loss of habitat quality, which is causing them to have to shift their ranges. Poppy.
So in the case of the penguins, penguins are affected by the main threats the oceans are facing, and climate change, of course, is one of the most important ones. In fact, most of the penguin species, climate change is the most commonly suggested cause of decline for most of the penguin species. But penguins are affected in different ways by climate change, depending if they live close to Antarctica or close to the equator. In general, climate change reduces the availability of food for the penguins. The penguins, what they need is they need food close to their colonies in order to feed their chicks. So penguins cannot fly. So they cannot cover long distances quickly. So if the food is far away from the colony, it takes longer for them to get the food and come back and feed the chicks. And by the time they do that, the chicks are already dead. So another effect that we see of climate change is specifically in Antarctica. Climate change is producing alterations in the pattern of ice formation and melting. So this changes the availability, but also the quality of the habitat that penguins need to feed, but also to breed. One example of this is that most penguins that live in Antarctica, they depend on krill, this little crustacean. Krill feeds on an algae that grows under the ice. Due to ice melting, there is less algae, so less food for the krill and less krill for the penguins.
Pretty dramatic impacts. So what about the cutest little monkey on the planet?
Well, cotton-top tamarins live in the tropical forests of northern Colombia, and they feed from fruits that come out from these trees. And this habitat it's got a very distinct rainy season 6 months out of the year, and a very dry season the rest of the year. So cotton-tops have a lot of food when it rains, and they have very little food when it doesn't rain, and they have to rely on insects and other sources, very scarce sources of food. So we're starting to see dramatic shifting patterns in the climate regime. So extended drier seasons, which mean they're challenging to find the food. And what we have learned with our long-time research is that cotton-top tamarin fertility and their ability to reproduce is directly linked to how much food they have. So no rain, no food, no babies in the forest. And that is the kind of impact that the shifting of the climate patterns are creating on the life of cotton-top tamarins. When we are talking about a critically endangered species, being able to reproduce, it's critical. So it's a high concern for our work.
Yeah, and it gets back to that point of being critically endangered. I had the pleasure of being with Rosamira this past year, and they are extremely limited in their range, and it has been heavily fragmented. So, when you've just got a few isolated populations and something impacts them, they're even more vulnerable. So we've pushed them already quite to the edge, and climate change can sometimes push them over, right? But let's just keep going with cotton tops for a second in terms of some indirect threats. These are you just mentioned some of the ones that we maybe sitting at a desk we might have expected because of the impacts of climate change. What have you not expected, or what's concerned you?
Well, some new threats that we have never had to consider in the past because of these shifting patterns in climate and drier seasons, then we're starting to get forest fires that are generated due to the dry seasons and dry storms, which is something that it was not common in our area in northern Colombia. So you get a dry storm, a lightning hits a tree that is dry after the dry season, lots of dry leaves on the forest floor, the fires spread very fast. And we actually, last year, had to face an emergency right by the forest where we work, and it was going into the forest, and it actually affected a couple of hectares. So forest fires is something that we never in the past, in the 30 years that we have been working in northern Colombia, had to face. And now we have to get ready to be able to reduce that threat and be ready to call the attention of all the emergency, the community, and us to fight fires now. And then when you have, just like you have hungry cotton tops, you have hungry people. If they rely on agriculture and there's no water to produce the crops, that's also a threat that forces people to hunt animals and cut trees. So those are two very distinct indirect effects of climate change that we are looking more and more in our work area.
So as you're walking around today and you pick up a brochure, for any one of these species, you often see a list of threats. What are we trying to combat? Well, we're having to actually add to that list now. The stuff that used to be written in indelible ink, we're having to add new ones because of climate change, ones that we never expected.
Yeah.
So thank you, Rosamira. Poppy, what about you? What are some unexpected things that you found?
Yes, one of the things that we have been observing is an increase in the number of days with extreme temperatures. In some of our colonies, we reported temperatures of 110 degrees Fahrenheit. So the penguins, they breed for 4 to 5 months, and they never abandon their chicks. But they do that, the only moment when they abandon the chicks is when they are about to reach their lethal temperature. So some nests are 1 kilometer far from the coast. So they leave the nest, and we reported an increasing number of adults that they die from heart attacks on their way to the ocean. So another surprising effect is that penguins, in their evolution, they have never been exposed to the fire because of the habitats they occupy. But as Rosamira explained, with the little cutest monkey in the world,
Have a beer.
Looks like we're having beers tonight, Poppy.
yeah. So we are reporting an increasing number of forest fires in places where penguins breed now. And penguins, since they don't recognize the fire as a threat, so they don't run away, and they stay in their nest with their chicks, and they all get burned and die. And another effect that is quite unexpected is that climate change is increasing the speed of the wind, and that increases the turbidity of the water. So imagine that you're a penguin and you have to capture a fish under the water. The turbidity reduces your visibility. You cannot see the fish, so you are less efficient to capture. So it takes you longer to come back to your nest and feed your chick. So that is increasing the mortality of chicks. And the last effect that we saw is that climate change is increasing the intensity and the frequency of some storms in critical moments of the breeding cycle when the chicks are small. So it rains a lot, then you have a couple of days of very cold weather. The feathers of the chicks are not waterproof, so they get wet, they lose their body temperature, and they die from hypothermia.
It's crazy. Elena, what about you? What are some of the unexpected impacts you've seen on Saiga?
Yeah. In my region, we have a very bad example of unexpected threat for the Saiga and all environment surrounding Saiga. That related with shrinking Aral Sea. I don't know if somebody of you already hear this name, Aral Sea. It's big internal sea that was located in Pre-Caspian lowlands of Eurasia. That started shrinking so strong in mid of 20th century because it was very terrible. It's still up now. It's not good extensive system of irrigation in my country, Uzbekistan. Which is one of the largest producer of cotton. We still continue produce cotton. This has required so many water resources. And after extensive using water from the two main rivers that came to the Aral Sea, this sea started to shrink very dramatically, very fast. And now, instead of sea, we have real desert that called Aral Desert. Is this area located exactly in Saiga area? And of course, it's very strong affected for the whole ecosystem. It's increased temperature, and increased dusting, and increased pollution as well. But at the same time, it's very strong effective for the human population. It's people who live around this Aral Sea. We're involved in fishery production. We have fishery factories. We have fishery itself. It's after shrinking sea, many people completely became jobless. Some of them immigrate from the country, but most of them started to looking for another source of income, and many of them started to be involved in criminal activity. And first of all, they started poach Saiga and to be involved in illegal Saiga horn trade. And of course, it's very strong increased pushment for the Saiga population, and it leads general declining Saiga population. You know, Saiga, one of the champion for the number declining. During the 10-15 years, we lost 25% of Saiga population.
So what we're actually seeing is not just these direct impacts of climate on the ecology of the species, but also in the economies of local people in the case of Colombia and in Uzbekistan, Kazakhstan. And then that has this secondary effect on people now poaching them, people creating new threats that we didn't really have when they weren't under such pressure from climate change. So it's, again, the amazing, shocking indirect threats. What about polar bears? I mean, there's the obvious loss of habitat, but it's more complicated than that, right?
One of the things that strikes me in listening to the other panel members here is when we talked about the direct effects, every one of them related to nutrition. And principally, or the first effect being survival of young, whether they be baby cutest monkeys in the world or antelope or penguins. And indirect effects are also very similar. So in the case of polar bears, in addition to the sea ice extent declining, one of the things that we've seen is that the ice is thinning as well. So even when there's ice there, it's not as thick, it's not as stiff or rigid as it used to be. One of my early discoveries was that in many parts of the world, polar bears actually denned and had their cubs out on the sea ice, but they can't do that anymore. At the same time, that thinner ice is farther away from the coast than it used to be, so the bears trying to get ashore are challenged by a long swim or getting to the denning area late. And there are some places across the polar bear range where it turns out that the date of freeze-up is now critical to when bears actually can get to the denning areas, and if it's too late, they don't get there and they don't have young. One of the interesting things, too, that I find in the northern environments where polar bears live, these bears come ashore. There are people that live there. And they have homes, they cook, they have the smells of food. And a hungry polar bear doesn't just come ashore and lay down and die. They start looking for food, and that brings them into contact with humans. So a real big challenge is how to prevent injuries to humans and also how to prevent those bears that are coming in ever greater numbers from being killed. So, it's all kind of tied together, and the similarities amongst all these species is pretty incredible, even though they live at kind of opposite ends of the world.
Well, let me just comment that, Elena, you need to get in the cutest little monkey comment, or otherwise you're not drinking with us tonight. So just keeping score here, I want to make sure that you're, and Rosamira, you're going to be a lot poorer.
Oh, boy.
So these direct and indirect impacts are obviously no laughing matter. They're a big deal. And sometimes it's not just those direct impacts, but it's the pressures that we've already put on these species that have made them endangered start to stack up. And then climate change becomes the proverbial straw that breaks the camel's back. Or it wasn't climate change that would have really had the biggest impact on the species, but when you combine it with all the other pressures, you end up with this sort of deadly cocktail of threats that in sum, cumulatively, can have a huge impact. And I've learned a lot about how that's impacting Saiga, and I'm wondering if you could talk a little bit, Elena, about that toxic cocktail for Saiga.
Yes, it's very sadly, but actually in the Saiga case we have situation of multiply effect, really deadly cocktail, different factors that work all together and very negatively affect for the Saiga biology and for the Saiga status in general. I already talked to you about pressure of poaching, I already talked to you about climate impact, but also we have faced with a very terrible situation when last year in central Kazakhstan, more than 60% of Saiga population was killed bacterial. It's pretty good known bacteria that called Pasteurella, and it was happened very fastly during the several days. We lost mostly females and babies. It was happened very soon after breeding season, and it was very suddenly for us because nobody was prepared for this situation. It's after this follows so many research and investigation, but still up now we don't know exactly what was triggered increasing these bacteria. And more likely that climate change affected because in a situation where temperature was changed and humidity was changed, and give some privilege for increasing number of these bacteria, and also increasing poisoning, pathogenic of these bacteria a lot. And all of this affected very negatively to the Saiga. But generally, we have situation decreasing general resistance of Saiga population because very strong pushment that multiply factor jointly all together that give us a very terrible situation, and suddenly that we actually could predict it in the future, because it's impossible vaccinate Saiga or limited their abilities for the movement. Now, still up now, it's very big challenge for us.
So just as some of you have heard about the disease outbreak that hit the Ethiopian wolves and how it could decimate their populations, that's what all it took with these populations of Saiga were already under so much pressure from direct impacts of climate change, from poaching, et cetera, loss of habitat quality, and then on top of that, a disease that they might have been more resilient to, it now becomes even more devastating. So it's just this combined synergy of these threats that climate change just sort of pushes them over the edge. But you know, we know that the world is going to be different. It's warming, yes. Climate is changing, yes. But it's a different world that we're all going to be living in. These species are going to be living in. Not all species are actually losers. Some are actually winners. It doesn't mean we think that's a good thing, but some species do a little bit better under this changing world. And I'm wondering, Poppy, you know, you work on 18 species of penguins. Are they all losing, or what's the story?
We have winners. So what is important to understand is that for all the species, they have evolved during millions of years. So they have matched their needs with what the environment was offering. So the day or the date when the chicks hatch is the moment of the year when there's more availability of food. So that happened during millions of years. Climate change is producing a mismatch between what's available in the environment and what species need. So in this case, we have most of the penguin species, they have these patterns, the breeding biology, you know, their timings are set, and they're not very able to move around that. So, but there is one penguin, which is the Gen 2 penguin, a very nice penguin. You can go to the table and I'll show you the picture of that one. It's very smart because it's the winner of climate change. So, for example, if in Antarctica the ice melts quickly, they rapidly adapt to that. They lay eggs, they nest, they build a nest, and they occupy the best places. So they are the winners. And the key thing, compared to other species, is that most of the species, once the chicks are big, they abandon the chicks on the colony, so the chicks have to go on their own to look for the food. The Gen 2s, they go with the chicks together, they teach the chicks how to fish, and they show them where the source of food are. So these are the strategies that are allowing them to be very flexible and win.
And of course, some of those species that are winning then can over-dominate and upset the balance, the ecological balance of a community, so they can start to become invasive species into a situation. So it really sort of disrupts the whole balance, at least of what we have known prior to this period of climate change that we've caused. So you know, I'm wondering, we talk a lot about polar bears and the direct impact on polar bears, and it gets to the point where you wonder, for a species so vulnerable at the top of the world, is there a tipping point at which we can't actually recover them? I mean, are we looking at a world completely without polar bears? And Steve, I'm just wondering if you can, what does it look like?
We don't have a tipping point in the sea ice habitat of polar bears. We published a paper in Nature in 2010 showing that there's a linear relationship between sea ice extent and temperature. So a higher temperature means less ice, but because it's a linear relationship, there's no sudden cliff that relationship falls off of. So we haven't exceeded, and we don't know about a threshold that would cause polar bears suddenly to be irrecoverable no matter what we do. And I think this is a really important and positive finding. Climate change is still the biggest threat, for sure, that faces polar bears, but we do have the opportunity to arrest it in time to change that picture and preserve polar bears. And I wanted to point out that with regard to winners and losers, one of the things we have to keep in mind is that if we don't take the action that we need to arrest climate change, this is not just going to mean the temperature rises a little bit and then levels off. It just keeps rising. And so what may look like a winner now may not be a winner in decades or centuries to come. We have to think about this in the very long run. But there is good news in there in terms of our ability to address the issue.
So we got to get to work. for sure. If we're going to slow that down, and the faster we get to work on that, the more polar bears we're going to have, is what I hear. So we need to make sure we're all each doing our part. We'll talk a little bit about what everyone here in the audience can do directly to ensure we've got more polar bears. But actually, Papi, I wanted to go to you and ask, to adapt to climate change, to these impacts. I know one of the strategies that you've been employing is marine protected areas, and I wonder if you could talk a little bit about the role of these MPAs, marine protected areas, in allowing species to survive in a warmer world.
Yeah, sure. So we recognize that in some cases we have very limited options to deal with climate change in the very short term. But what we can do is improve the stewardship and the management of our human activities. So in that way, we reduce the pressure that we put on penguins so they have a better ability to cope with climate change. This is what we call improve the resilience of a species. So in our case, a good tool is a marine protected area, which is a place in the ocean, and it could be also on land, where all the human activities are ordered in time and in space. So I always make this comparison, like it is like a house in which you say, okay, this is a space, this is going to be a kitchen, we are going to cook here. And this is the living room, we're going to sleep here. You're not going to cook in the living room, and you're not going to sleep in the kitchen. So in that way, you protect the structure of the house and the function. So the same thing happens with the environment. So we divide the marine protected areas and we say, okay, you can fish in this amount, in this moment of the year. So in that way, we reduce the overlap and we minimize the conflicts between human needs and wildlife needs.
Great, and especially in the case of MPAs, they often are places where they're what we call sources. They're places where, for example, the reproduction can happen where species can do better and then feed out into other parts of the other similar habitats in the ocean. But you've got to have those sources to enable these populations to recover, right? So critical work. Papi's doing a lot of work on that, as is Rachel Graham of the Mar Alliance to establish those MPAs, and they're vital if we're going to have anything like what we had in the oceans in a warmer world. Rosamira, the cutest little monkey in the world. I got to visit the cutest little monkey in the world. Are you keeping track, Steve?
You're 7 or 8.
All right, excellent. So like I said, I got a chance to visit in Colombia, and what struck me was the strategies and the creativity and the new partners you've had in terms of creating new reserves and connecting them up. Can you talk a little bit about that and why it's important for climate change?
Yeah, in order to for species to adapt to these changes, they need to be able to move around freely to expand their opportunities. And what deforestation has created in northern Colombia is fragmentation. So you get little islands of forest scattered around the areas, and cotton tops never come down to the ground. They always hang up in the trees and move around the trees. So when you get fragmentation, basically they stay isolated. And in order to counteract that, our work is focusing a lot of our efforts in building forest or creating forest, planting lots of trees along the waterways and along the ridges and areas that are difficult to do any other activities. So those are saved for trees and for creating forest, and we can start connecting the dots, just basically with lines. And so cotton tops in the long term, they can move around. And the fun thing is that actually what's good for cotton tops is very good for humans as well, because while you're protecting all these watersheds and the waterways, you're also securing water for the people when the dry season comes. And they have water for their crops, and they also have food. And then, of course, benefiting all of the other animal species that live in the forest where cotton tops are. So our efforts right now are very much focused on creating forest, planting lots of trees, creating these corridors to give cotton tops and other wildlife the chance to move around and adapt to these climate changes.
So this is a really important point, because it actually goes across, no matter what your favorite species, even if it's not the cutest little monkey in the world, corridors are really, really important in a warmer and more crowded world. We've got a lot more people, a lot more impact, but we've also, these species need the ability to roam. They need that freedom to roam, to move. Even if they're not migratory, like the Saiga, they do need to be able to move and get to other habitats as their habitat shifts upwards or northwards, but also to be able to get to other pockets of habitat that still exist, so they're more resilient. So if you do have that forest fire come through and hit San Juan, for example, there are other habitats that the cottontop have inhabited because of these corridors. So it's a really vital strategy, whether you're talking about painted dogs, you're talking about Saiga, whether you're talking even about some of the sharks and rays that Rachel works on, and even with cottontops. I won't even say it. I think I'm well ahead.
Everybody knows it now.
Yeah, everybody knows it by now. So I'm wondering if we could, now I think what I'd like to do is maybe open it up for some questions and answers, but we're not going to end just there. We're going to stop a little bit before and talk about what you can do, because I think that's what was on everybody's mind as well. So I think we've got some mic runners who have got their running shoes on. So we're opening it up for questions and answers. Yeah. Is
Any?
We'll repeat the question. Yeah, go ahead.
What's the global population of polar bears today? And secondly, how adaptive are these polar bears to their new circumstances with less ice and having to go on the mainland?
So
Steve, can you repeat the question for us?
The question was, how many polar bears are there in the world? And oh yeah, okay. How adaptive are they? I got a good memory, but it's short. Let's take the second one first. The second one, you might see a lot in the media about, polar bears will be okay. They can just move on to land. And what we've shown is that they really can't. There are some places where some number of individuals might be able to make a living or at least supplement their food stress period, their food shortage period, by catching a few things on land. But the bottom line is that there just isn't enough nutrition in the terrestrial environments of the Arctic to support polar bears. And the best example of that comes from Mother Nature. Adjacent to the polar bear populations that live offshore are grizzly bears that live onshore. And those grizzly bears are the smallest of all of the brown bears. They're tiny little bears, and they live at very low densities because if you're a bear, that habitat isn't very good habitat. So we can't imagine that we could move whole populations of the world's largest bears into a habitat that currently supports only small numbers of small bears. The question about the numbers of polar bears is an important one. Jefe said, well, we're dealing with endangered and threatened species here. That means they all have minimal numbers. Actually, polar bears, if you consider their whole range, are still fairly abundant. There's about 20,000 or so in the world, which compared to a lot of things, that's a lot.
Yeah.
The problem is, and they were defined as threatened not because of how many there are now, but because it was very clear that there were going to be ever less and less and less as we go into the future. So the problem with polar bears, and again, this is kind of a bright spot, we have enough out there that if we can get on top of the climate problem and stop the rise of greenhouse gases, we can actually have a lot of polar bears left.
Yep. Great. Other questions? Yep.
I have known for years that whales eat krill, and I was interested to find this morning that so do penguins. There's a product on the market called Mega Red or Omega Red that for fish oil, or that ingredient in fish oil that's made from krill. How much does a product like that threaten animals who have evolved to eat the krill, whereas the humans have absolutely no reason to be buying krill?
Yeah, thank you. Thank you for your questions. Yeah, we were concerned about the Mega Red and other products that come from krill. We are dealing with very big fisheries in Antarctica, and all the marine mammals and all the seabirds, they depend on krill and other species there. So the thing in Antarctica is that there is krill availability there. The problem is when the fisheries, they fish just in front of the colonies. So they deplete the abundance of krill in that space. And as I said before, penguins cannot fly, so they cannot go further to get the krill. one of the things we're dealing with is that some of the fisheries in the world are certified. That means that they use, the correct ways, and they are fishing the amount of fish they should do that. The problem is that some of the fisheries of krill, they don't use nets anymore. So they pump the water out of with the krill and with everything that comes. So the efficiency of the fisheries is incredible. And the krill in Antarctica, they form very compact, dense, like super swarms. So if you put that boat and you suck all the water, you fish a lot. And particularly, so you can deplete very easily the availability of krill close to the colonies. So we are working with the certification process to improve that, to make sure that when they're certified, it's okay. And of course, we are working a lot with the CAMELAR, which is the organization that regulates what's happening in Antarctica, to make sure that there is a spatial management of the fisheries. Okay, you can fish this, but you can fish it out here, not in there. So this is how we deal with the problem.
Thank you for the question. I think we've got another one over here.
Yeah, thanks for a great panel discussion. My question, as I understand it, please correct me if I'm wrong, I think the polar bear was the first species actually listed as an endangered species specifically due to the threat of climate change. And I am wondering, what does that actually mean in terms of management and conservation? Are there actually teeth in the Endangered Species Act that allows us to combat rising carbon emissions? How can wildlife protection allow us to address the climate crisis through various endangered species acts or their similarities internationally? Thanks.
The polar bear was the first species listed based on the future risk of climate change. And so it was a landmark decision in that case. Unfortunately, the teeth involved in that were pretty minimal. And in fact, the US federal government basically wasn't able to address, the USGS and the Fish and Wildlife Service were not able to even address the risk of climate change until very recently. And it's only been within actually this year that federal agencies have been able to speak out more effectively about what the real risk is. Fortunately, we are turning that around. And in fact, our chief conservation officer at PBI sits on the Polar Bear Recovery Committee that involves all of the federal agencies and a whole bunch of other people. And we are actually seeing climate change now being addressed as the #1 issue. But for a long time, it wasn't. Now, what we do about it, of course, is we need policy change. And so to the extent that those people, whether they're our guy that's with an NGO or university professors or whoever, to the extent that they can change the minds of the policymakers, that's where the real challenge is. But we are very slowly making headway. And I have to admit, I was very chagrined because I thought we'd put out our reports in 2007. Secretary Kempthorne declared polar bears threatened in 2008. And I thought, okay, I can breathe now. But it's been how many years since then, and I still can't quite breathe.
A lot of work still to be done, and it's actually a preview for a lot of other species, wolverines, lynx, and other things that are going to be taken in on the chin. So, unfortunately, there's a lot more episodes of this series. So, yep.
Hi. Thank you for this. If we imagined a perfect scenario where all the countries that ratified the Paris Climate Agreement actually followed through on what they hope to do, what would be the rate in which greenhouse gases would be slowed? How many years? And would it be enough time for these species to recover?
Steve, maybe you can answer the policy question and the greenhouse gases, and then maybe everyone else can comment on the hope.
The Paris Agreement is huge. And although as a friend of mine always says, the devil is in the details. The details of how we're going to reach the Paris goal haven't quite been worked out yet. But if we can achieve that, we can hold global mean temperature below about 2 degrees. We might not make the Paris goal of a 1.5 degrees. We might. a lot of that is in the uncertainty of what actually happens in the real climate that we experience. But we can stabilize the climate by the end of the century and going forward continue to have a stable climate that it'll be at a higher baseline, but it will save most of the species that we're concerned about.
So do any of you have a sense for your species, your habitats, a sense of what 2 degrees looks like? Papi, have there been any studies for penguins, for example?
Well, the fact is that, for example, in the Antarctic Peninsula, in the last 60 years, the temperature increased 40 degrees Fahrenheit. So it's like if you have your freezer, you take the ice, and if 2 degrees is the difference between ice or water. So those things are very important. Of course, we know it is going to take a long time, but you have to address issues in the short term, very short term, and in the long run. So this is very important because it's going to affect what's going to happen in the long run. And then the future comes. At some point, you meet the future. So this is very important, and we know it's not going to be easy, but it has to be done, and it has to go to that level, high political level, to make it happen.
Steve, go ahead.
Yeah. One thing that I should clarify is that when we talk about a 2 degree threshold or a 1.5 degree threshold, we're talking about global mean temperature. And people say, well, 1.5 degrees, I can hardly tell that. But what that means is that summer temperatures might be far higher, winter temperatures maybe not so much, and in some parts of the world we'll see less warming than others. So we can't sort of think that, oh, well, 2 degrees, that doesn't really mean anything to me, because in some places that might mean 14 degrees.
Right.
And it means complete and utter loss of a lot of habitat, coastal habitat, alpine habitat, even at that level. So, and some of those habitats like mangroves becoming completely dysfunctional because of the way the water chemistry works. And so it's a big, 2 degrees is not a scenario we really should have ever found ourselves in. I think there's another question right here, and then I think we have time for maybe one more.
Thank you. Wildlife corridors, we know how important they are, and yet you talk about as global warming happens, the habitats shift. How can you integrate shifting habitats, shifting wildlife corridors, as you fight for someplace, one corridor, and then it changes?
Rosamira or Elena?
I'm not sure I understand the question, though. It's how do you approach the shifting patterns on one side and the additions on the other side?
So predicting some of these wildlife corridors,
yeah.
given the shifts in habitat. Yeah.
Well, I guess it takes a lot of monitoring. It's we're trying to rebuild a landscape that was there in the past, and that due to human activities, it has been destroyed for over the last 5 or 6 decades. It takes time, and it takes a lot of monitoring, and it takes a lot of intervention along the way, so you can make sure that all of the research you have done and understand what the species need is replicated in these corridors that you are creating, in the forest that you are creating. And at the same time, it requires to somehow tackle the shifting patterns by protecting as much as possible what is there still, and trying to avoid that disappears, and then somehow influence the diminishing tendency of the forest that the wildlife need to provide. And it is a little unpredicted to know in the next 30, 40, 50 years, but you have to start now, and you have to start rebuilding it. And we've done enough research and enough testing to be able to produce something that works for cottontops and that works for the rest of the wildlife that share a home in those forests in northern Colombia and in other places.
Yeah, so oftentimes scientists will model where they think habitats are going to be shifting, but then we've also closed off some of those opportunities already. So it's not like you're working with a blank playing field, nor are these species super flexible in how they can respond, right? And so we know how some of them move or what they need to eat and feed on when they're migrating, and so that starts to constrain the options. And then you know that in some places we've already created obstacles for where those corridors could be, and we have to deal with those. And so I think when it's a great question, and it's a complicated one, because you start to you have very few degrees of freedom to find out where you're going to be able to have these corridors to get to where we think the habitats are moving. It's not a perfect planning scenario. There's a lot of unexpecteds as we discussed, but really, as you've heard, these corridors and securing the cores, including, as you say, where habitats are shifting, are absolutely vital. So, you know, the work of a lot of people who are trying to set up those corridors is absolutely vital. And we'll talk about this momentarily, but it does mean that we have to also broaden the group of people we're working with, because that means a lot more land needs to be managed in a way to protect these species. Poppy, and then we're gonna.
Okay, just a brief comment, because it's very different in the marine environment. Because on land you have this land, it is a protected area, but in the water you have a mass of water. It's here. Tomorrow it's going to be somewhere else. You know, so it's very difficult. It's very virtual. So we're using these models that kind of help us to predict what environment is going to be useful, and also the change in the currents, because the food is coming from somewhere, and if that changes, then this area is not going to be useful anymore. So what we're using now is that you have a core area where you protect what you care, then you have other areas, and then the outside is a buffer zone. So we are expanding the buffer zones, and we are adding flexibility to the laws so we can adapt to that and quickly move the core area, you know? So as the Gen 2 penguins, we also need to be flexible, you know?
Absolutely, great point. Yeah, Elena, quickly.
To it very quickly, some new context. In transboundary area, sometimes it's very difficult to have a political solution about joint conservation of species which have transboundary migration. It's a very important issue, and one more issue is organizing transboundary protected area. I think it's very good for protection such mobile species who move on big distance, or areas of species that was shifted from one country to another one. It's necessary to keep international context.
That is a great point. These transboundary protected areas, and the Saiga Conservation Alliance has been doing a lot of work with that, because the species spans so many countries in Central Asia, and so without that kind of transboundary protection, which is not easy whatsoever, we will lose the species. So I want to close by just asking two quick questions, and we'll keep it brief. And Steve, I'm wondering if you could say what the audience, in your perspective, what the audience can do to address these challenges for wildlife.
Global warming and the climate change symptoms that accompany it kind of turn our whole idea, our whole model of conservation on its head. Because it used to be we'd send people out into the field and protect species or build fences or whatever. But we can't build a fence to protect the sea ice from rising temperatures. So this really is about us. It's not something that we can do in the field. And everybody in this room needs to reflect on how you're living and see what you can do to change that so that you have less impact, less of a footprint on this world that we share. And then, most importantly, you need to influence your policy leaders, whether you know senators or congressmen or mayors or governors, whoever you can influence, that this is a real challenge and that all of the species that you care about are being jeopardized by this, and it's something that we can do here.
And vote.
I second that.
Any which way you want, but vote. Rosamira, you're addressing some really practical solutions on the ground. Is there anything people can do to help with those sorts of things for adaptation?
Yeah, definitely. Like I mentioned before, it takes, you can probably tear down a hectare of forest in a day. It takes probably 20, 25 years to get it back to where it was. So with the corridors, with creating more habitats, we're going to need to plant lots of trees. We're going to need to spend a lot of time making sure they grow and they become a forest that cotton tops can use, or many other wildlife and people as well. So there's an opportunity to support the work of creating more forests, or adopting a corridor, or helping us plant trees, or helping us monitor all those trees so we can effectively accomplish our mission to create more forests for animals in Colombia. Then, we're surrounded by people that are working all around the world here today and supporting their efforts of making a difference for wildlife and impacting the shifting patterns of climate change.
So choose your species, choose your conservationists,
Right.
choose your strategy, but whatever you do try to help them, because each and every one of them is working to adapt to this warmer, more crowded world that we live in. And on that note, I would like to close the session by just saying that this problem is bigger than any one organization. It's bigger than any one political party. It's bigger than the conservation community. It's going to require businesses. It's going to require each and every one of you. It's going to require the conservationists, governments around the world. It's going to require all of us. And until we sort of open our arms up and reach out, even to those we might have vilified before, we're going to have to do this together. So I think that is one fundamental message I think we need to take out of this session. And please do spend some time with these conservationists. Talk to them about their amazing work that they're doing. It is through them that we will have these species in a warmer world. So thank you very much for all your time today. And to the panelists.